Venus is the only planet where every mission is a one-way trip. Not because we lack the technology to leave, not because the rockets can't handle the journey back, but because Venus itself won't let anything survive long enough to make that return possible. Think about that for a moment. We've sent humans to the moon and brought them back. We're planning missions to Mars with return trips included. But Venus? Venus is different. And by the end of this video, you'll understand why anyone stepping onto that planet has already made the most final decision of their life. People imagine Venus as Earth's twin. Similar size, similar mass, both rocky planets orbiting in the habitable zone. The marketing almost writes itself. But here's what they don't tell you in those comparisons. Venus is what happens when a planet becomes a furnace that never turns off. The surface temperature sits at 470 degrees Celsius. That's not a temporary heat wave or a sunny afternoon. That's the coldest it ever gets. Day or night, summer or winter, equator or pole. Lead melts at 327 degrees. Zinc liquefies at 419. On Venus, both would puddle on the ground like water. Your spacecraft, your protective suit, your electronics, all of it starts breaking down the moment you arrive. So, you might think the solution is simple. Build better heat shields. Use materials that can withstand extreme temperatures. Engineer your way out of the problem. Humanity has always been good at that, right? But here's where Venus reveals its first trap. Heat isn't the only enemy. In fact, it might not even be the worst one. The atmospheric pressure on Venus is 92 times that of Earth. Stand on the surface and you're experiencing the same crushing force as diving 900 meters below the ocean. Except there's no water, just thick, suffocating carbon dioxide pressing down from every direction. Your body wouldn't explode like in the vacuum of space. It would compress, slowly, relentlessly, like being squeezed in a vice that never stops tightening. Every seal on your suit, every joint, every structural component of your lander faces this constant, unforgiving pressure. And unlike the deep ocean, where pressure is distributed evenly by water, Venus adds heat to the equation. Materials that might hold under pressure alone start to weaken. Metals creep and deform. Polymers soften and fail. Nothing stays rigid for long. But surely we've thought of this. Surely engineers have designed systems that can handle both heat and pressure simultaneously. They have. Soviet Venera probes proved it's possible, surviving on the surface for up to 2 hours before dying. 2 hours. Not 2 days, not 2 weeks. 2 hours of functionality and then permanent failure. This is with unmanned probes built specifically for suicide missions. No humans inside. No life support systems running continuously. No plans for a return journey. Just cameras and sensors, and even they couldn't last. Now imagine a human mission. You need power generation that works in those conditions. You need cooling systems to keep the interior of your habitat survivable, which means expelling heat into an environment that's already hotter than your cooling system can handle. You need communications equipment, navigation, life support for however long you plan to stay. And all of it has to function perfectly because there's no repair crew coming. There's no spare parts shipment. Once something breaks, it stays broken. What about the atmosphere itself? This is where Venus shows its third trap, and it's arguably the most insidious. The atmosphere isn't just hot and dense. It's actively hostile. Clouds of sulfuric acid drift through the sky, concentrated enough to dissolve metal. Rain that would burn through your suit never reaches the ground because the heat vaporizes at mid-fall, but that doesn't make it harmless. Those acid droplets are part of a cycle that continuously corrodes anything exposed to the atmosphere. Your landing gear, your external sensors, your communication arrays. Everything on the outside is under chemical attack every single second. Inside your habitat, you might feel safe, but maintaining that sealed environment becomes a nightmare. One tiny breach, one microscopic crack in your protective shell, and Venus starts seeping in. The pressure differential means the atmosphere doesn't just leak, it forces its way through any weakness. And once it's inside, you're not just dealing with pressure or heat anymore. You're dealing with acid eating through your internal systems. You're dealing with toxic gases that can kill you in seconds. The margin for error isn't small, it's non-existent. But here's what most people miss when they think about Venus. Here's the real reason why no one who goes there is coming back. It's not any single factor, it's time. People think the biggest challenge is surviving the landing, or lasting through the first day, or making it to the planned departure date. But the truth is far worse. The clock starts ticking the moment you enter Venus's atmosphere, and it never stops. Every second exposes your systems to conditions they weren't designed to endure indefinitely. Heat fatigues materials. Pressure creates microfractures. Acid corrodes protective coatings. And none of this happens in isolation. They work together. They amplify each other. A seal weakened by heat fails faster under pressure. A corroded surface creates new stress points that accelerate structural failure. Your equipment doesn't break suddenly. It degrades, gradually, inevitably. And the worst part? You can't predict exactly when the cascade will happen. Think about what this means for a return mission. You need your ascent vehicle to remain functional, not just intact but fully operational. Every explosive bolt has to fire, every fuel line has to hold pressure, every guidance computer has to boot up perfectly. After sitting on Venus for days, weeks, or months, experiencing temperatures that melt lead, pressures that crush submarines, and acids that dissolve metal, what are the actual odds that everything works when you need it? Soviet engineers calculated that their Venera probes had a survival window measured in hours. Modern materials might extend that to days, maybe with significant advances in technology, weeks, but a human mission would need months. Time to conduct research, time to justify the enormous cost and risk, time to make the journey worthwhile. And every additional day on the surface multiplies the probability of catastrophic failure. This isn't pessimism. This is mathematics. This is engineering reality. Even if your ascent vehicle somehow survives the surface intact, you face another problem: launch windows. On Earth, if a launch is delayed, you wait a few hours or days and try again. On Venus, your launch window is the time between when you land and when your systems fail. Miss it, and there's no second chance. The fuel you brought is finite, the power you have is limited, and Venus is slowly destroying the machine that's supposed to save you. Can you imagine that psychological pressure? Knowing that every hour that passes makes your rocket less reliable, makes your chance of survival smaller, makes the decision to stay just a little longer potentially fatal. But let's say somehow everything works. Your ascent vehicle fires on schedule. You make it off the surface. You reach orbit. Are you safe? Not even close. Because Venus does something that makes orbital rendezvous uniquely challenging. The planet rotates so slowly that a Venusian day lasts 243 Earth days. Your orbital mechanics are operating in an environment where the ground beneath you barely moves. Matching velocities with a return vehicle or station becomes complicated in ways that don't exist around Earth or Mars. And all of this assumes your ascent vehicle has enough fuel and power for complex orbital maneuvers after surviving the surface, after systems degradation, after months of waiting. The reality is even darker when you consider the mission architecture. A proper return mission would need redundancy, backup systems, multiple ascent vehicles perhaps. But each additional system you bring is more weight, more complexity, more things that can fail. And all of it has to survive Venus, the environment that destroys everything we've sent there so far. You're not just fighting against heat, pressure, and acid. You're fighting against the fundamental physics of an environment that's incompatible with sustained mechanical function. This is why no space agency seriously plans human missions to Venus's surface. Not because we lack ambition, not because the science wouldn't be valuable, but because the engineering requirements for a safe return exceed what's possible with current or foreseeable technology. Mars is cold, but manageable. The Moon is airless, but predictable. Venus is hostile in ways that compound and multiply until survival becomes not just difficult, but statistically impossible. Some scientists have proposed floating cities in Venus's upper atmosphere, where temperatures and pressures are more reasonable, and that might work. But the surface? The place where we'd need to land to study the geology, to understand why Venus became what it is, to learn the lessons that might help us prevent Earth from following the same path. That surface is off limits. Not temporarily, not until we develop better technology, but fundamentally. Because Venus doesn't just kill machines and humans, it kills the possibility of rescue. It kills the idea that help can arrive if something goes wrong. It kills the assumption that survival is even an option if you stay too long. So when someone says they want to go to Venus, what they're really saying is they want to die there. Because once you land, once you step onto that scorching, crushing, corroding hellscape, you've entered a place where the universe has stacked every possible card against your return. The heat will weaken your ship, the pressure will crack your seals, the acid will eat through your defenses, time will betray your technology, and eventually, inevitably, something critical will fail. And when it does, there's no backup plan, there's no rescue mission, there's no second chance. Venus doesn't negotiate. It doesn't offer compromises. It simply exists as a permanent reminder that some places in our solar system aren't meant for us. Some doors once walked through don't open from the other side, and anyone who chooses to go there has made a choice that's more final than almost any other in human experience. Not a journey, a destination, one way, forever. Thank you for watching. If you want to explore more about the deadly realities of space exploration, you might find the next video interesting. I'd be very grateful for your support, and I'll see you next time.